how to manage the currents related to an LED luminaire. So let's consider that we have a photometry coming from our laboratory. GF is the photometry automatically produced by our goniophotometers. And so we can simply drag and drop the photometry over here. Once you have the photometry in, we may add the image, and at this stage, we can start defining the other parameters, like the flux and power in function of current. We select this feature. This window will appear, but I see that one parameter should be defined before. So let's say that we define the channel 2 current, which is the current sourcing the LEDs. So in this case, we say 355 milliamps. Apply. We select the flux and power in function of current. This is the situation, the set of values corresponding to the main photometry. Let's say the complete photometry. Let's now add the other set of values. For example, we measure at our goniophotometer, keeping the luminaire at the same position at the end of the main photometry, let's say at gamma 0 towards our photocell. We drive the current from 350 to 500, for example. And keeping it at the same position, we measure the lux value after the stabilization period. Once we reach the stabilization, we measure the lux value, we convert it to the intensity, and then we take the intensity at gamma 0 corresponding to 500 milliamps, and the current and the intensity corresponding to the same position, but with a current of 350 milliamps. We make the ratio, and we apply the ratio to this flux, finding the other flux value corresponding to 500 milliamps. At the same time, we also measure through our multimeter the corresponding power. So we do in this way. We input 500 milliamps. We say that the corresponding flux level is 3251, which corresponds to a power of 28.6. Then again, we repeat the measurement, for example, at 750 milliamps. We come now to a value of 3321 and a total power of 29.6. We update, and so we draw the curve. In this case, we are drawing a curve which has a quite huge concavity, which is not exactly corresponding to the real situation, but it is only to give an idea. Once we have defined the three set of points, we can, through this feature, we can define all the current, flux, and power in between. So, for example, if we want to start through the power, and we say that I need to have the current corresponding to 27 watt, we simply input here 27, we update, and so we will have this other point corresponding to the new situation. If we want to have a higher flux, for example, we may have how much is it in terms of current and in terms of power if we want to have 3,300 lumens. The program is saying 0.675 milliamps, which corresponding to 29 watt. Once we have defined the new set of values, we confirm, and automatically we have here the new set of values, and through them we can save to LDT or IS files or any other file format. Let's remember that an LDT file can carry only a single value of flux. It doesn't have any chance to manage current, like it is possible through an OXL file. In fact, if we select OXL, we can save now this configuration. And let's say that we close now this photometry. We have the OXL file. We simply drag and drop, and that's it. We still have the current, the flux and power in function of current diagram.